Okay, let us go for preparation methods. So there are three types of preparation. That is, first one is from alcohols, from alcohols, and then second one from hydrocarbons, from hydrocarbons, and third type is halogen exchange, halogen exchange reaction, right? So from alcohols we can go for three methods. That is one from halogen acids, right? HX, one from halogen acids, and another method is from phosphorus trihalides or phosphorus pentahalides or thionyl chloride, associate thionyl chloride. And another method is red phosphorus dihalide. So this red phosphorus dihalide X2. So this in turn will create a trihalide in the reaction, right? That's a method. And hydrocarbons, let me write here. Hydrocarbons, we can go for two methods from alkanes and alkenes. And alkenes, two methods we can go for from hydrogen halide, HX, and here from simple dihalides, X2. And halogen exchange reactions, we are having two types here. Finkelstein reaction, another one is Schwarz reaction. Finkelstein reaction, you have to remember sodium iodide and dry acetone. Sodium iodide and dry acetone, we have to relate it to the word Finkelstein, right? Sodium iodide and dry acetone. Schwarz reaction, you have to remember metallic fluoride, especially AgF or SbF3 or Heg2F2. These things you have to remember regarding the Schwarz reactions. Let us get into detail. Let us go for the first part from alcohols, right? From ROH, right? So we had divided into three parts now. First thing is from halogen acids. That is ROH plus a halogen acid, HX, right? So what happens here? The water gets eliminated here, and we can have remaining part RX plus H2 right? A simple reaction. Got it? Let us have an example for this. CH3, CH2, OH plus HCl. So what happens here? As usual, this goes away and this gives rise to CH3, CH2, Cl plus H2, right? So this is in the case of alcohols. That too, in the case of primary alcohols, we have to use note. Make a note here. For primary and secondary alcohols, we have to use ZnCl2 with HCl. So this is called as Lucas reagent. And primary alcohols and secondary alcohols only react with the halogen acids in the presence of ZnCl2, right? But tertiary alcohols, no need of Lucas reagent. No need of Lucas reagent here, right? Because the tertiary alcohol, the carbocation will be more stable. Just make a note. Tertiary carbocation more stable. Tertiary carbocation is more stable, and simply by shaking these two, the reaction will take some time. By shaking with halogen acid, we can prepare it. Simply by shaking the alcohol with the halogen acid, we can prepare corresponding alkyl halide in the case of tertiary alcohol. But in the case of primary and secondary alcohol, we need the Lucas reagent here, and temperature also required. But here the tertiary alcohol takes place in the room temperature. Room temperature. So the Lucas reagent is used to distinguish between the alcohols. Got it? So this is also an additional point you're gonna have. Next thing, what happens when this alcohol, that is alcohol, reacts with HBr, hydrogen bromide. Here we have to use H2SO4. The same kind of reaction takes place. What is your ultimate aim? Where ultimate aim is to make an alkyl halide. So write the alkyl halide here. That is RBr, right? RBr. And H2SO4, as usual, what is the role of H2SO4? It is a dehydrating agent, so that it removes water from the. So this is a reaction when we are using the RBr. But instead of RBr, if you are using instead of HBr, hydrogen bromide. Let me write all this from the very beginning. Right. In the case of hydrogen bromide, ROH plus HBr, we have to use a dehydrating agent like H2SO4. The same kind of reaction takes place. What reaction takes place? As usual, the H2SO4 will go away because it's a dehydrating agent. We can have RBr plus H2O, right? Okay. But in the case of potassium bromide, ROH plus KBr, if you use a dehydrating agent here, H2SO4, same H2O4 if it is used here, let us write the ultimate aim of our preparation, that is RBr, potassium bromide will be formed, plus, and here there is OH, and here HSO4 is there. Now let me write one H from here will join with the OH here. So let us make HSO4, H2O, plus what is the point remaining? K will be remaining here. Here HSO4 will be remaining here. So KHSO4 will be formed in the case of potassium bromide. Potassium bromide. In the case of potassium bromide, KHSO4 will be formed, right? In the case of iodide, let us take iodine here, ROH, alcohol plus, let us take iodine, hydrogen iodide. So we have to employ H3PO4, phosphoric acid. We have to employ H3PO4 here. So again, the same thing will happen as in the first reaction. This will give rise to, that is in the case of hydrogen iodide, again, Ri plus H2O will be here. It also does a role of dehydration. The same reaction, when it is treated with ROH plus potassium iodide, what will be the product? Just guess it. H3PO4, right? So as usual, what will happen? R alkyl halide will be there. It is alkyl halide will be there. And here an OH is here, and here one H will be removed here, plus H2O. What is the remaining thing there? Plus H2O. Here K is remaining here. Here, what happened? One H has been removed. H2PO4 is here. So this is KH2PO4 will be formed. Potassium phosphate will be formed. Potassium hydrogen phosphate will be formed in the case of potassium iodide. Got it? So this is the end of the first step, that is preparation from alcohols. So it's in the preparation from HCl, HBr, and HI, right? HCl, what we have to use? We have to use ZnCl2, right? In the case of primary and secondary alcohols, tertiary alcohols will take speciation. HBr, we have to use H2SO4, and HI, we have to use H3PO4, right? Phosphoric acid. So these are things you have to keep in mind. Got it? Okay. Next, we can go for preparation from PCl5 or phosphorus trihalides or phosphorus pentahalides, right? From PX3 or PX5. So let us have it as that is PCl3. Let us have PCl3 here. ROH plus PCl3, right? So what happen? Obviously, we'll have RCl. So let us write RCl. What is remaining here? Plus OH. Here OH is there. Here PCl2 is there. PCl2 is there. So here 3 chlorine is there. If you make it as 3 ROH, what happened here? 3 RCl will be there. So 3 chlorine will be utilized here. And remaining 3 OH will be here and 1 P will be here. So 3 OH, 1 P, let us write as H3PO3, right? Phosphorus acid will be obtained in this reaction. The same kind of reaction will happen in the case of red phosphorus. ROH will provide red phosphorus X2. So this will give rise to PX3 only. PX3. So again, the same set of reaction. That is ROH plus PX3. What happened here will happen here itself. Got it? And here you remember the red phosphorus will be used here as well as in HVZ reaction. No doubt. HVZ, and here preparation of haloalkane. So red phosphorus, you have to remember these two things because these two are the places where red phosphorus is employed for you. Got it? Right. So let us write this equation, that is ROH plus, in the presence of red phosphorus X2. So that will give rise to PX3. So again, the same sort of reaction will be there. 3RX will be there plus H3PO3 will be there. The same set of reaction, what we have written, plus H3PO3 will be there. Got it? So this is in the case of PX3. Let us go for the case of PX5. So ROH plus, let us take PCl5. PCl5 here. So here obviously RCl will be there. So it gives RCl plus, here HCl molecule will be eliminated in this reaction plus HCl. So what is remaining here? Here one O is remaining, one P is remaining, two C has been eliminated. One for chloride, one for alkyl halide, one for HCl. So remaining 3 is there. So what is remaining? One phosphorus is there, one oxygen is there, and 3 chlorine is there. POCl3, phosphoryl chloride. Right off. This is phosphoryl chloride and it's a gas. Phosphoryl chloride will be obtained in this reaction. Got it? So this is happens with the phosphorus pentahalide. Right? Next, the last thing and the most important in NEET JEE is Darson's process. Darson. This is A, right? Let me write again. Darson's process. D-A-R-Z-E-N. Darson's process. Darson's process means what we are going to do? We are going to react ROH plus thionyl chloride, SOCl, thionyl chloride. Obviously, our aim is to make an alkyl halide, right? RCl. And H is there, Cl is there, so that HCl will be eliminated here. And what is remaining there? SO is there and one O is there. So SO2 will be eliminated. Here, these two things, that is the HCl and the SO2, are in the gaseous state. So this will evolve easily. And this will be the purest form, pure. No need to purify this one. So that this process is used to make pure alkyl halide. No need of purification required in this process. Got it? So far we had seen that preparation of haloalkanes from alcohols and alkyl halides PX3, PX5 and thionyl chloride SOCl2, right? The next thing that is a preparation from hydrocarbons we'll see in the next video. HC preparation from hydrocarbon we'll see in the next video. If you have any doubts, just comment. Thank you.